Hello, everybody. Welcome to this episode of the BimTube Podcast. Today we've got Peter Kohler, who I've known for several years. So thank you for joining me, Peter.
Thank you. Thank you for having me.
You're very welcome. And normally what I do, of course, I know the people I talk to very well, but normally what I ask is if you just introduce yourself, currently what you do and what you want to say about yourself, but also, which is, I think, very important for people listening or watching this podcast, is how did you get into what you do? So you can take as long or as short as you want on that. And the reason is, as we've already discussed before, the sort of core audience of this podcast are people that are maybe not from a technology, digital or data background. So it's really fascinating, I think, how people have had different journeys. So please, over to you, Peter, just introduce yourself and how do you do what you do?
Hi, I'm Peter Kohler. I am a senior marine litter scientist at the Centre for Environment, Fisheries and Aquaculture Science, or Cefas for short. And what I do at the moment is mainly just focusing on automated ways to monitor marine litter, and also I've got a really big interest in developing national action plans with partner states that we work with on the international stage. So you've got the automated monitoring side, and then you've got the kind of applying that within a national perspective. So that is very interesting relationship between the two. I think how I got started, I've always loved geography. I wanted to do something in geography. My dad told me to go for something that's going to get you a job and all that sort of stuff. I didn't think at the time, and I think quite wrong now, but I didn't think geography would get me a job. So then there's a new thing called GIS, Geographic Information Systems. And so I thought it sounds pretty good, computers and maps, that could go somewhere. That might be something important. So I did that as an undergrad. And then I kind of got a job in London, and that's kind of where I met you, I think, Stephen, part of the kind of GIS community. We always had kind of similar, I think, views on the GIS, and in that it's a part of a bigger machine sort of thing. And then so I worked there until in that industry in local government in central London all the way up until 2018, when I got a job in Cefas. It's quite a career change from GIS manager at the time to marine litter scientist or marine pollution scientist. And I think that started way back in 2008. I did some traveling around the world, and I ended up in the South Pacific, and sailing between islands. I could see that there was litter everywhere. And that really bothered me. Like, how does it get there? It's, you're hundreds or thousands of miles away from the nearest civilization, and yet there is huge amounts of litter washing up on beaches, and then also seeing the damage and the impact and that caused to local populations as well as wildlife. So I came back, and I continued my GIS thing, but I attended all the ocean events I could possibly manage to attend in London, which is quite fortunate because London has a lot of events like that. Met a few people, a few inspiring characters. And then I had the idea where I wanted to actually apply for a Royal Geographic Society grant, which was, you get a Land Rover and a bunch of money to do an expedition of some description. The idea was to drive along the West African coastline and sample litter on the way to highlight that the damage it causes to societies of different kinds and that sort of thing, but also to maybe provide a bit of knowledge to science. Then I realized that it would take a very long time to do all that monitoring manually, and I had an interest in drones back in 2015, and I had a friend who did a lot of machine learning, this newfangled thing called machine learning. Of course, by that point, to people in the field, it's quite an old thing, but to a lot of other people, it's quite a new thing. So we applied it. We did a little test run. It seemed to work quite well. Flying drone over a beach. And so then it turned out that I couldn't get the money to go around the West African coast, but I managed to get some money together to go around the UK coastline. And we captured lots of images. We founded a charity called the Plastic Tide. We got citizen scientists to annotate that litter that the images found, and then that went into a proof of concept algorithm. And basically trying to scale that idea up. That's where Cefas got interested, and that's how I ended up partly in Cefas. A whole kind of career change. From London all the way out here to Lowestoft in Suffolk on the east coast of the UK. And I think that's hopefully people are still awake there, Stephen. That's a good.
I am no. That's a good journey. So so it was nearly Africa, and then we've got but you were off. Like you say, you observed initially these things far away in the first instance. So I mean, it's
Oh yeah. Yeah, I mean, it always bothered me anyway. Like, litter, I think it bothers many people, but it always did bother me. It's just the fact that, seeing it in pristine environments where it, really should not be, and then trying to figure out why it got there, how it got there, what was causing it. I think that really kind of bothered me for the following, 10 years after that. I applied. It was. When I was away traveling, there was something called the global financial crisis, which we got when I got back. I didn't really have many job prospects. I actually applied to go on a tall ship as crew, or the Royal Borough of Kensington Council GIS analyst, and the GIS analyst job came up, and that's what I did. So,
but so you were nearly a singer on a cruise ship. No, I know you didn't, but you could have been. What could have been?
Yeah. I could have been a world-renowned cruise ship entertainer. No.
So
there's still time, Stephen. There's still time.
There's still time, and you can always have a career diversion. Of course, people famously have multiple careers now as well. So you've still got time once you've cleaned up the oceans here, but priorities. I dare say it's best to stick with what you're doing at the moment. So thanks, Peter. It was a fantastic overview from what you've done and where you are now. And I guess we will obviously get into some of the technology. Like I say, this is for an audience maybe not so technically literate, but nevertheless, that's core to what you do, and it's pivotal and essential. So this may seem a crazy question, but just what is machine learning? You mentioned machine learning. So just for the novice among us, before we start talking about maybe some of the techniques that you use, what is machine learning at a fundamental level? So
I'll give the high level definition. I think it's a form of AI. So when people use artificial intelligence or AI, they often interchange that with machine learning. And I think it's just important to realize that machine learning is a subset of AI. It's not AI as a whole. And essentially, it's very loosely approximates a kind of neural network. I think it might annoy hardcore machine learners to say that it kind of mimics a human brain, but it's a very loose approximation in that you can. There's different forms of it, but in essence, you can train an algorithm to automatically detect items, whatever it is that you train it on, and that can range from objects to cars to litter, as I'm doing, and you just keep feeding it examples. Some algorithms can learn from the image you put in. It learns to kind of segmentate itself and recognize what different objects are. But in essence, it goes through a process and it produces an output of what it has been trained to identify. And yeah, I think that's probably the highest level of definition.
Yeah. But maybe something we could just mention is the concept of training. We probably talk hours about the detail, and I agree with that point. But just the concept of training comes up quite. Can you just just, I mean, maybe you've just described it, but the concept of giving in your case more images and then confidence levels, is that just very brief overview of what the sort of training is in machine learning?
So you can, if you forget the pun, you can get rubbish in and rubbish out with algorithms, right? So machine learning algorithms, it's very dependent on what the training material is and how well annotated that training material is. So you essentially just, in our case, you feed it lots of images, and then you demarcate, if you will, the litter in those images, and you say this is litter of this type, and then you feed that into the algorithm. It then learns from that input and then tries to replicate those results in data that it's never seen before. And that's the real advantage because of the way the process works. And I won't pretend to understand the details of how that machine learning process works, but the way it works is that it can then identify, in my case, litter in images it's not seen before. And the confidence that it's able to do that is dependent on that input data. So it needs as much variance of examples of that item as possible. The more variance you give it, the better it can identify that item. But interestingly, it can also be biased by your own biases, and some of them you may not be aware of. So I think in some medical diagnoses, for example, to do with skin conditions, a lot of the training data was on Caucasian skin, and so it didn't. The algorithms weren't quite effective in darker skin tones. So it's important to realize that it's a very interesting kind of reflection of us, as it were. I think machine learning is this big evil thing, or potentially a big evil thing that can change and take over the world, but it's just a reflection of us and the biases that we have, and we train it if we're not careful. The more complex an object is, the more you need to train it, as I've said. So a car generally will be of a certain shape with 4 wheels, whereas a litter item can be of all different shapes and sizes and colors. And then also it needs to learn the backgrounds as well. So if you train an algorithm on litter on sandy beaches, it will be very good at detecting litter on sandy beaches because that's what it's learned from the input imagery. But it won't be very good if it suddenly sees litter on a pebble beach or a rocky beach. So there's all sorts of kind of considerations when you're doing it. But I think that's
Thanks, Peter. I'm just thinking about there's hundreds of different permutations, aren't there? Is that where you described it as demarcating or the different objects, features? Is that where you've had citizen scientists get involved, volunteers, in other words, who have helped with that?
Yeah, so the annotation. So quite often, particularly if it's like we've been describing litter, where there's lots of different shapes and sizes, you need lots and lots of examples. And you have to sit there and you have to draw around those examples often. As I said, there are versions in which you can ask the algorithm to kind of come up with your own as well, sort of unsupervised. But the supervised classification is where you sit down and you say that this is a litter item. And what we did with the citizen scientist side, because that takes a lot of time, we did an experiment. We outsourced that to the public to draw basically just bounding boxes around the litter items. And then that was fed into an algorithm, and that could train that algorithm into detecting it. I think we had 8 different classes at that time, or 7, because one was unknown, which kind of isn't really a class. But so you do have to kind of digitize it. But there are companies now. There's lots and lots of companies that basically just had a call. Apologies. There's lots of companies that basically have that provide that as a service. So they'll annotate for you, and then you kind of set the parameters. You say what you need annotating, and then you release them on it. But in those things, particularly with complex subjects, QA QC is really important.
Yeah,
quality assurance in that.
Yeah, thank you. To discriminate. And what is the main types? Again, genuinely interested in the topic. What's the most prevalent type of litter? I mean, I wouldn't have any idea. What What is there out there?
It's a really good question. It just depends where you are, really. I think I would be fairly safe in saying that in most cases it's plastic fragments. So it's where larger bits of plastic have just fragmented into smaller bits, right? So, I think there was some quote somewhere that said a plastic bottle could fragment into 1 trillion pieces of microplastics. So it breaks down, and that breaks down, and that breaks down. It doesn't, with plastics, they don't dissolve, they don't disappear. They just break into smaller and smaller and smaller pieces. Like a bit of glass that you smash into like little pieces, and you smash up those pieces, and you grind those pieces up, and it's pretty good. So that's
yeah.
Yeah.
So forever it's plastic. And do they? I mean, again, this might be obvious for us, but maybe for the people listening or watching, one of the biggest challenges is then it bioaccumulates, so the animals eat it. Is that studied? I know maybe you're actually looking at the litter, but as far as like the parallel consequences, is there evidence that animals actually eat it, or is that something else that's going on about studying the animals?
Yeah, so the impacts of it, so you got something called macroplastics, which tends to be, generally speaking, above 5 millimeters. I mean, you've got like meso and macro and micro and nano, but effectively above 5 millimeters, it's considered macroplastics. And then below 5 millimeters, it's considered microplastics, right? The macroplastics, the larger bits of plastic, I mean, you can get entangled. A lot of ghost gear is quite popular now. Discourse in the general media, and that's just discarded or lost fishing gear made of plastic. Problem is, it never breaks down, and what that does is it can potentially continue to catch fish. So that impacts on the commercial yields and the livelihoods of people, because the more fish get caught in those nets than could have been caught normally. Obviously, you get the really charismatic megafauna, there's dolphins and the whales that get caught up in the plastic or that eat the plastic. So there's entanglement, there's ingestion. So the animals eat it. It fills the stomach up, and they can't pass it through the digestive system. So they basically feel fuller and fuller. And so they don't eat because they feel stuffed, because they've got a belly full of plastic, quite literally. And then they weaken, and they're more susceptible to diseases. And then quite often they die because of that, unfortunately. So that's the kind of macro level. And then also plastics can get snared up in propellers and cause all sorts of havoc with navigation and maritime industries. But then there's also a lot of research coming out that they're quite effective disease vectors. On some of them, you can get little microatmospheres or little protected bubbles, which can transport either an invasive species or some sort of disease from one place to another, which wouldn't have really been possible before because of how durable plastics are. And then if you're going down to the micro level, there's a lot of evidence and research that we do that shows that chemicals and contaminants absorb or basically get attracted to plastics, because that's a petrochemical and it attracts other petrochemicals. And then there's some evidence that when you eat that, because you're inhaling microplastics now, it's in the dust, it's everywhere, right? I mean, from micro all the way down to nano, which is, I forget what the exact size ranges are, but super tiny, basically. And then at that level, it can potentially pass through the gut barrier and into your system. And there's still a lot of research going on about, what does that do to our hormones, to our organs, that sort of stuff. So that's very much a kind of active field of research at the moment. But it is known that it can absorb chemicals and it can release them. It's been demonstrated in labs, at least, that microplastics can affect the behaviors of fish larvae and that sort of thing. But it's quite hard to prove that for certain in the marine environment, right? So, for example, it's hard to tell if the chemicals that are generally in the environment anyway, were they the cause of that fish getting ill, or was it from the microplastics that fish consumed or that fish larvae consumed? So they've demonstrated in the lab where they can control all those variables, but in the real world, I think that there is evidence showing that it does, but it's much harder to kind of causally prove that link.
Great. I mean, not great. I'm just listening. Great for your explanation. Terrible for what you're describing. But I was just thinking about some of the other that it's so big. You know, I mean, literally, we're talking at a global level, aren't we? I was just thinking of the other information data sets of what you use. I mean, again, maybe for people listening and watching, because there'll be other data sets like ocean currents and that. Could you just give a quick overview of what other information sets or data that you call on, whether it's oceanographic or whatever, just to give a sense of what's going on here? Because there's a lot of modeling of, I mean, to us obviously, but what's the other data sets you draw on?
It's a huge amount, right, Stephen? And that's something that I think a lot of scientists are trying to get grip of, this, you know, kind of quote unquote big data issue, where there's a whole plethora of data that have access to potentially that would be really useful, but we don't necessarily have the infrastructure to access it, and the software to access it, and the licenses to access it, because it's a lot of data to be handling. But things like, as you say, ocean currents. There's a lot of remote sensing data around water temperature, water color. There's lots of data around salinity of water. There's atmospheric conditions. There's emissions. There's all sorts of very relevant things to plastics and to climate as well. And there's a few papers, including some that we produced, that show that a lot of climate change. There's a link cause between plastic pollution and climate change as well. Not least through the burning. Like a lot of waste is burnt, so that generates a lot of carcinogenic toxins when plastic's burnt. So that's a lesson. Do not burn plastics. They release a lot of nasty things into the air. So there's a whole range of data, from satellite to sensor-based data to scientific survey data. It's all, and I don't think we're always so great at kind of bringing all that together into one place, sort of thing. So
yeah, it's very difficult, just the awareness as well, isn't it, to have a catalog. I'm sure there are some different sources, but there isn't sort of a global universal catalog of geographic information that I'm aware of. So I think that's probably half the battle often. Again, I don't know about your sector, but generally, you did, just to pick something up if I can, you mentioned QA, QC, and I skipped over that, so apologies. I didn't, again, for people new to sort of information management, governance of data and things, what is checked? I mean, again, there might be obvious things to us, but what is checked? What are some of the fundamental things that are checked for data quality?
Well, QA, QC, I mean, that's a very fancy acronym that makes you sound really good. That's just quality control and quality assurance, right? And a lot of that is, you'll get errors if you outsource, and if the thing that you're annotating is particularly complex, like litter. We're trying with a lot of categories, like 96 categories. And what that means is that there's a lot of variance. And if you present a litter item to someone, it's called like kind of inter-rater error. Someone will say it's this X, and the other person will say it's Y, and that will confuse the algorithm. And so you need to have person A and person B saying it is the same object. Otherwise, the training data is you're going to get really low accuracy levels and confidence levels. So you have to have a kind of a golden truth, a kind of what is this item. And again, it's not always clean cut, particularly in litter. There's all sorts of challenges that you have to be aware of. So, for example, there's the way we classify items can be dependent on its use, or can be dependent on what it is. For example, plastic container, pretty unmistakable, right? It's like a container with a lid, and you can pour stuff out of it. But then, quite often what can happen is people will cut holes in the sides of those containers, and then it becomes a whelk pot. And then that item, then potentially becomes discarded fishing gear. And if you train the algorithm and tell them, no, that's a plastic pot, and there's lots of these converted whelk pots in the environment, what you're going to find is that you then present that data to an environmental officer or a policy expert, and you say, hey, you've got a lot of plastic containers in your environment. And so then they introduce some sort of policy or some sort of preventative policy for that, and potentially you find it misses the mark. It targets the plastic container industry rather than the fishing industry where the litter came from. So there's all those kinds of nuances and differences, and the more complex the subject matter is, the more complex they get. And so you need to have a very solid quality control process, and that involves really understanding what it is that you're annotating, providing really kind of clear definitions of what is and what isn't an object as much as you can. And then when the annotators, whether that's your own organization or if another organization is, you have to kind of go through and sample all of that annotation to really understand how accurately that data is just going into the algorithm itself, right? Before the algorithm does anything, you need to make sure that you're providing it really quality assured and robust data sets. Kidding. I don't know if that answered the question.
Yeah, no, absolutely. No, because you're living at this data quality challenge, and I think certainly the BIM in the BimTube means better information management. I think that's it, isn't it? If we are involved in data, and you're obviously a data scientist in that way now, it's most people aren't. Most people, that is not something they give much thought about, if any thought about. And then when it is discussed, the importance perhaps isn't clear. Like, we should have quality information or data, and people say, well, yeah, obviously. But then the potential complexity, and I like the example you gave of, it was a bottle, for example, and now it's a fishing equipment, and what the semantics around it. So it's all very, very relevant. It's a similar parallel with things like BIM, the other context, building information modeling for the built environment. The semantics of what things are and depends who you're asking. So I think it's all very relevant, and of course metadata. Just very, very briefly, I know we're sort of kind of talking about it there, but what metadata do you use? Do you have a metadata catalog? Again, this isn't standard practice for a lot of people, believe it or not, at least not by name. So what do you do about metadata?
We capture it sometime. So for the beaches, it's very important when you do a survey to understand what the aspect is. Where was the beach facing? What kind of material it is? Is it used regularly? There's a whole kind of manual monitoring protocol around that, right? And so what we want to do is we want to capture that as part of the automated monitoring. You want to have that metadata associated with that data set, right? But you'll have lots of things in terms of metadata. You'll with the drone imagery, you'll have the GPS position and all that. That's captured as part of it. With the annotations, they're kind of associated with the image. So you have a kind of, I'm not a machine learning programmer, but I understand that it will be referred to. So you'll have an annotation, and that will be localized to a particular part of that image where that annotation was made. Whether that's box-wise, which is just drawing a box-wise, or polygonal, which is where you draw a shape around to match the size of the item itself. But that plays a really key role in it. And there's also coming up with standard terms and terminologies for everything is also incredibly important. And there's some work generally in the machine learning field to start doing that. So, that if it's a spoon, everyone calls it a spoon rather than a an oval shaped object, a stick with an oval, or a shiny silver feeding implement. There's all different ways of people describe the same. And it's the same thing in litter as well. People describe plastic wrapping in 1,500 different ways.
So on that theme, and just out of interest, is there an internationally recognized classification for litter, or are you effectively making it, or is there a sort of a UN, for example, recognized classification?
So it's a really good question. So there's a UNEP, United Nations Environment Programme protocol for litter, and that's what we call them. We call them kind of marine litter protocols. And then Europe has its own one called OSPAR, which is kind of connecting. You can map it over to the UNEP one, and obviously we use that because it's Northeast Atlantic, and we're in the Northeast Atlantic. But there's a whole plethora of other protocols around the world, and quite often they're designed for different aims. Some are designed more for policy, so there's a lot more classes, there's a lot more detail, and then some are also just designed for outreach, so it's a lot simpler, but you don't really have the kind of real detail in the classifications. And we use our OSPAR one in our algorithm, but what we're very clear on and what's very important is that every region, and pretty much in most cases, most nations have their own litter fingerprints, as it were. So there are general items, the most common ones, like I said, plastic fragments. The other real common ones are single-use items, sweet wrappers, takeaway containers, cans, drink bottles, those sorts of things. Those tend to be the most common ones. But countries will have their own products that are only available in that country or in that region. A common one is like little drinking sachets, which in the Caribbean you get a lot, but you don't get them here. So they're literally like a plastic pouch of water. You just kind of bite the corner off or tear the corner off and drink it. So it's not even a bottle; it's just like a little plastic pouch. And you don't get them in Europe, but you get them in the Caribbean, and I think in some African countries, as well as I'm sure in other places around the world. But they can cause particular issues as you find lots of them in the environment. So, that in itself is something that is going to be an important part of the algorithm development, is the recognition that it needs to be contextualized to the location it's being deployed in, essentially.
Yeah, that makes perfect sense. That there'll be local and unique items. Again, that concept transcends across lots of different sectors. Similar. Obviously, we're talking about very important things here, saving the environment, but we're on sort of more mundane things that I used to get more involved with in the rail sector, for example. It would be the same thing. You get unique. There's some things are common, some things are unique, and then having to communicate. I just out of interest, because you mentioned policy a few times. What are the outputs, or what I mean is either maps or dashboards or whatever it is, reports. What are things that are produced? Just even the class of them, maybe not even specific examples, but what are the outputs that are produced by you or your colleagues that are used for policy? What do they look like?
Again, it depends where you are. So OSPAR is quite a well developed. OSPAR is the Oslo Paris Convention. It's just like basically northwestern European countries or northwestern Atlantic countries, essentially, is what OSPAR does. And in many cases we agree environmental standards, and we measure using indicators against those environmental standards. So one of the indicators, for example, is in plastic contaminants or plastic content in fulmars. The other one is number of litter items per 100 meters as well. So that's you get those indicators, and that shows the level of that contaminant in that environment. So I've just given you examples for plastics. I can't really tell you what examples there are for other pollutants, but they do exist. There's a convention for mercury, for example, which kind of states unsafe levels for mercury and what you should do about that, and how to report it and all that sort of stuff. So that's more at the more developed end. And then in the developing end, where those kind of systems aren't in place, and it's it can be quite basic reporting, like top 10 items, top 10 plastic items. I mean, that's universal, right? And that's quite useful in terms of just targeting those areas. You know, we would find in certain countries, we found metal bottle caps were extremely prevalent, and that was related to the behavior that I think, based on the local knowledge, is that a lot of people just assume that because it's a metal bottle cap, it will degrade in the environment. You know, which it will potentially. I mean, quite often they've got plastic infills on the underneath of the cap which don't degrade, but then it takes a long time for that metal to degrade, and in enough concentrations that can have an environmental impact as well. But it's also a valuable source of metals that could be recycled. So, you know, that's quite helpful in then being able to design solutions to that. So, you know, you could have a container return scheme as a popular one, which includes the bottle cap. You know, sometimes you have to state that, you know, return the bottle and the bottle cap, and then you get, you know, money back. So when you buy the bottle, you pay like a deposit included in the price of that drink or whatever. Then when you return that bottle, whoever returns that bottle, they get that kind of deposit back. And so that's kind of proven as quite an effective way to, you know, ensure that bottle's returned back in or recycled. But yeah, so I mean that's an example of the policy that might come out of it. So from the very developed, where you've got frameworks, you've got monitoring frameworks, you've got kind of indicators, you've got targets for, you know, how good you want the environment to be. So your EU has kind of environmental standards, or good environmental standards, that it will define. It will say, you know, for a healthy beach or a healthy system, you need to have below X number of items per 100 meters. And then, you know, the monitoring can then report on that. You know, another example is with the plastic bag ban in the UK. After that was introduced, we found, particularly on seafloor litter, there was a marked reduction in the amount of plastic bags that came up. So that's the other aspect of it. If you're going to introduce a policy, you need to then measure if it's worked. And, you know, you can't manage what you can't measure. So if you don't get that baseline, you could say it's meaningless. You can't say that you've reduced litter by 20%, or because you don't know what the state was before you made the intervention. And then it's also, you need to be careful about what you're measuring is actually what's happening. You know, if there is a big reduction in plastic bags, is it causally linked to the policy that was implemented? And that's really important to know. I mean, some people might think, yeah, whatever, it's a reduction, it's fine. But because those interventions cost money, and they often, it involves the public doing something, you know, you want to make sure that you can show that effort, that investment from time from the public and money to get it done has actually had an impact. It's actually made a difference. And so that's where you have to be that's where the science comes in. You have to really think about the indicators and how you're monitoring it and what you're monitoring, you know, and there's all sorts of different considerations around that. And there's a whole kind of group in the marine litter world, a group of experts that come together and think about these problems and produce kind of guidance and that. So
yeah, thanks, Pete. I was thinking about, and you said it there, that's where the science comes in. That's exactly what I was going to comment. So you took the words out of my mouth there, where again, in some other domains I tend to work in, it's not, people don't, that conversation about are things statistically valid, you know, we'll talk a lot about outcomes and benefits and adding value of using information in a smarter way in other sectors. But then that scientific approach of it probably isn't there, let's put it that way. So again, you're literally a scientist, so it's like, we need the metrics, we need to, is this statistically valid, if I can even say it. And I think that's because for people that don't know me, I did science as well. I actually studied environmental biology, believe it or not. So this is most interesting to me, but I think that's the thing where that's often lost. You know, you'll get data people, maybe not data scientists per se, but lots of people working with data and information who basically aren't scientists. I'm not saying they should be, but they don't have a scientific background. So that that sort of going back to basics is missing. There's probably nothing for you to add other than a comment on that. I'm just backing you up on the scientific thing. I mean, yeah.
Oh yeah, I mean, I think the other challenge is that in a lot of the developing world, who are often more vulnerable to the negative impacts of litter, right? It causes all sorts of havoc in that area, and I think, you know, on a brief tangent, you get a lot of island states that you know, that have tourists or have you know, obviously have an industry. Bottling, lots of plastic bottles will go to that to support that for drinks and stuff. But once that content is consumed, that plastic cannot be moved off the island because it's too expensive to move it off the island, which is crazy. I mean, if a bottle of water, it's just water, you drink that water on this island at X or whatever island you want to call it, and then it's stuck there. It can't move off it. The plastic itself, which is from petroleum, is worth less than the water that you just drunk, that you could potentially get from a spring or from a, you know, and so they, in some cases, and I've seen it myself, you can get a mountain of plastic bottles because they can't be transported off the island. So I mean, I digress slightly there, but related to that is, you know, a lot of developing states don't have a lot of money to implement these huge, you know, these monitoring programs of the size that we have in global north that they have. Even then, it's quite difficult to get the funding to monitor properly. Hence, this is what I breathe, live and breathe, right, with the automated monitoring. So there's a lot of cost in terms of people's times and people's effort and finance to monitor the environment. And there's the automated monitoring, automated AI, particularly machine learning, offers a very powerful way to kind of automate and scale a lot of this challenge. And you know, you'll get in developing states, like, they just don't have the people or the capacity to monitor, so they can't. You don't get that baseline to start with, or it's very difficult to get that baseline. And what you don't want to do is just not have any action. On the flip side, you don't want to not do anything because you can't monitor it, because clearly something needs to be done about it. So there's a challenge. There's a challenge there where there's a lot of kind of, look, just get it, just start doing something. And this is where kind of innovative technologies around AI and that, for example, but also other areas, other ways of automating things, even just better data sets, better, easier to deploy databases and good licensing conditions for those databases that favor developing states, I think is really important to, once they get that information, to then store that information and share that information effectively without needing an army of database experts to, you know, and tens of thousands of dollars to make 5 changes to it. You know, that really inhibits a lot of this kind of data and intelligence gathering in this kind of in the resource constrained environment, you know, such as so that's a very long way around it. But essentially, what I'm saying is that rapid surveys are also quite effective way of getting those baselines, and we've done those in the past. But there's some really important points in developing states around, you know, developing resilient technologies that can operate in those challenging conditions really effectively, because most of them are designed for, you know, London offices, you know, or US offices, or Bulgarian offices, you know, developed nations where there's a lot of resources and know-how to do it. So I mean, that's an important thing to say, is that there's the ability is there. It's just quite often it's the capacity. It's just this, you know, there might be, in some cases, there might be 150 plus islands in the nation, and there's only maybe 3 people in the environment department to look after all of that. You know, and you're not really going to have a lot of time to go out and monitor things. So
Yeah, it's a good point, because then it comes down to priorities, or as perceived priority and long-term view. I think what would be interesting, because we don't have long left, got maybe 10 minutes, is just, so I think we've set the scene. What, I guess, on a positive side, or a solution side, what's and I know there'll be many things, but what sort of solutions are happening? Like, what's being done? Are there maybe 2 or 3 examples of clear solutions? You've alluded to some, but maybe specific examples of what either governments have done or individuals have done to improve things. It would be great to hear about that, if you could.
Oh yeah, so there's the UN Treaty on Plastic Pollution, which will create the first legally binding treaty for member states to tackle litter. So at the moment, largely it's been kind of voluntarily based. A few regions have implemented binding legislation, but mostly it's just been volunteer based, and that's currently under discussion. Maybe 2 years, maybe longer. That will hopefully come to fruition. So that's really exciting. That's really good, and that involves all stakeholders, from private sector to NGOs to scientists to everything. So I think that's a really positive way forward, and that's something that's needed. I think a lot of people, at least in the marine litter area, marine debris area, think that the challenge is akin to climate change, simply because the cross-sectoral nature of waste and litter it doesn't respect any boundaries. It's all over the place, and I think there's lots of examples of how there are solutions that are coming up. So, for example, there's products that involve less plastics, reductions in packaging, which a lot of companies are implementing, which is really good to see for plastic packaging. There's a lot more awareness of the sustainability side of it, and I think that's a really important marked shift in our relationship with our planet. Is that, in many ways I see us as, children who have had all these toys and we've been playing with them, and we suddenly realized that actually we've caused quite a bit of damage when we've been playing with them, and now we're trying to figure out, well, how do we play with them, or how do we use them differently in a way that's not going to damage where we live. And I think there's probably quite a lot of parallels to that in the wider world, in that we've got all these products. Up until now, we've thought the world was infinite. We could keep pumping stuff into it, whether that's waste or exhausts or CO2, and now we're kind of realizing that actually it's no longer a fringe hippie, say hug a tree thing. There's a serious, as there always has been, a serious financial considerations and business considerations in, you're not going to have a business if you destroy your market, and the market exists in the planet. So I think that's a really positive shift, but I think we need to do more, as always. And then, you've got lots of cleanup operations like Seabin and, the ocean cleanup crew. They've gone through lots of challenges in offering them, but I think it's a multi-pronged approach, right? So, monitoring is a key element. It's what I do a lot of, but I don't want everyone to spend lots and lots of money in monitoring, because then they can't spend that money in prevention and cleanup. So it's really important to turn the tap off before you then start to clean up the environment. And there's lots of really good movements into that area, and I think one of the most basic elements, Stephen, in doing this is the perception of our environment and our relationship with that. And I think a lot of good things will flow from a healthier and more sustainable view of that, I think.
Great, thank you. I completely agree with you, and I think even when the topic hasn't directly been sustainability or the circular economy, in some ways with everybody I've spoken with, it's come up at some point, which you'd be pleased to know, particularly things like United Nations Sustainability Development Goals and the ultimate sort of purposes of and why. So I think the messaging certainly is coming through, and things like ESG, environmental, social and corporate governance type targets as being a requirement. So it's happening. It's happening. What I don't hear enough about is about the condition of the oceans, though. That's the first time it's come up directly, is talking with you today. So the implication is land, no doubt, or drinking water. We don't have much time left, so normally what I ask, so thank you first of all for your time. Amazing. We're not quite done, because normally what I ask people is, if people are interested in this topic, where would you suggest they can go on the internet? I'm sure there are 100 websites, but maybe just the top 5 places you recommend someone that's probably new to this topic. Are there any that spring to mind?
In terms of marine litter,
yeah, and maybe getting involved is the implication, but I guess that's what I'm asking directly. Yeah, just to learn more, and then maybe how they might participate or volunteer would be great as well.
Well, so there's things like Ocean Conservancy's one. It's kind of a global setup that does, for that you can set up your own beach clean, and you can volunteer, and you can offer data. They've got apps, very easy to use, very good for outreach, and they're probably the biggest global database of litter. In the UK specifically, there's the Marine Conservation Society. Lots of fantastic resources there around marine litter and that sort of and those sorts of things. The UNEP, United Nations portal, has a lot of good information and links off to other places. Ellen MacArthur Foundation has links as well. Grid Rendell is another good place for links. Promote my own organization, Cefas. We also have links to marine litter, but also just more generally kind of marine pollution and that sort of thing in the general area. So there's lots of places that I think you can go, but I think the primary ones would be kind of UNEP, Ocean Conservancy, those organizations, and then they'll take you off to various areas.
Yeah, great, thank you, because obviously I'll link to them. That's so if people want to read more around it, or hopefully get involved as well, then I'll have a sort of it'll be an easy way to find that information. So we have run out of time. Thanks, Peter. I could talk all day, but again, in only 1 hour, it's simply about giving an overview and then wayfinding, pointing people to where they can get more information as well. So thank you very much for your time and your insights, and thank you for the work you're doing. I certainly, for one, am very, very interested, having like I say, a background in environmental biology. It's maybe I've slightly deviated from my path, but you're certainly in there with the cutting edge activities. So it's fantastic that you are, and thanks for your time. So thank you. Thanks, Peter Kohler. And hopefully we'll maybe do another one day. Let's see what feedback we get, but I certainly enjoyed it. It's fantastic. So thank you.
That sounds great. And a big hello to your listeners. And yeah, thanks for having me, Stephen. It's great. I hope it's been helpful and informative.